Hello, I am Mamleen. Welcome to my general mathematics class.
Good day. This is a continuation of our topic about rational functions for week 2. Let's proceed with the content standards. Again, the learner demonstrates understanding of key concepts of rational functions. Performance standards. The learner is able to accurately formulate and solve real-life problems involving rational functions. Our lesson for the day, for lesson number 3, is about solving rational equations and inequalities. So let's first have a recall. Let's simplify the given rational expression x minus 2 divided by x squared minus 4. So as you can see, x squared minus 4 is a perfect square binomial. So we can factor this out to expand the expression. Then the numerator x minus 2 divided by the factors of x squared minus 4, which are x plus 2 times x minus 2. So as you can see, we have common factors x minus 2 that can be both cancelled. Therefore, our final or simplified rational expression will be 1 divided by x plus 2. Next, we multiply the given rational expressions 3x plus 1 divided by x squared minus 1 times x plus 1 all over or divided by 3x squared plus x. So you can see on the first expression, x squared minus 1 is a perfect square binomial, so therefore we can factor out this expression. Now on the second term, we have on the denominator, x can be factored out from the expression 3x squared plus x. So rewriting the expression, we'll have 3x plus 1. The factors of x squared x squared minus 1, that is x minus 1, and x plus 1. Second term, we have x plus 1. Factor out x, we have 3x plus 1. Common factors, cancelable. Okay. Next, finalize or simplified form is 1 divided by x times x minus 1. Now, next is to find the sum of the given rational expressions with like denominators. So, we have common denominators. The expression 5x minus 1 divided by x minus 8 plus 3x plus 4 divided by x minus 8. So, we rewrite the expression using the common denominator x minus 8. So, 5x minus 1 plus 3x plus 4. Let's combine like terms. 5x plus 3x minus 1 plus 4, x minus 8. Simplify, we have 8x plus 3 over x minus 8. Our last exercise is to find the difference of the given rational expressions with unlike denominators. So the expressions are 6 divided by x squared minus 4 minus 2 divided by x squared minus 5x plus 6. So both denominators are factorable. So we can factor out x squared minus 4. It is a perfect square binomial. Therefore, the factors are x minus 2 and x plus 2. Now for our next expression, x squared minus 5x plus x plus 6 is factorable, and its factors are x minus 2 times x minus 3. So getting the LCD or the least common denominators, we have x minus 2 and x plus 2. X minus 2 is also common, then x minus 3. So LCD will be x minus 2 times x plus 2 times x minus 3. So this LCD will be multiplied to this expression. So we have x minus 2 times x plus 2 times x minus 3 multiplied to the given expression 6 divided by x minus 2 times x plus 2 minus 2 divided by x minus 2 and x minus 3. Okay, so first we are going to multiply this LCD to the first expression. So cancelable po on x minus 2 and plus 2. What will be remained is x minus 3. Therefore, we have 6 times x minus 3. Next is we multiply the LCD to the second term. Common factors, we have x minus 2 and x minus 3. Ang may iwan po is x plus 2. So 6 times x plus 2 all over the LCD, that is x minus 2, x plus 2, and x minus 3. So this we distribute, this should be 6. We distribute the constant value 6 and 2 in each factor. So we have 6x minus 18 minus 2x minus 4 divided by x minus 2, x plus 2, and x minus 3. So combined like terms, we have 6x minus 2x, that is 4x. Negative 18 minus 4, that is minus 22, all over x minus 2, x plus 2 times x minus 3. So this is the simplified form for the given expression. 6 divided by x squared minus 4 minus 2 divided by x squared minus 5x plus 6. So to check our answer, we have here the answer. So let's check if our answers are correct. Number 1 is 1 over x plus 2. So that is correct. Number 2 is 1 over x times the quantity x minus 1. Number 3 is 8x plus 3 over x minus 8. And last is 4x minus 22 over x minus 2 times x plus 2 times x minus 2. So far, tama naman po lahat ng mga sagot. Okay, we proceed with our main topic. That is, first, steps in solving rational equation. Let's learn how to solve rational equations by solving this given example. Expression x minus 3 over x squared minus 25 plus 1 over x plus 5 equal to 1 over x minus 5. So the first step is to find the least common denominator. So let's simplify first this expression. We have x squared minus 5 is factorable. So we have x minus 3, x plus 5 times x minus 5. So that is a perfect square binomial. So the next expression is also already simplified. And the last expression is. Therefore, our LCD from this expanded form, we have x plus 5 and x minus 5. Okay, so common denominators are x plus 5 and x minus 5. Next step is to multiply both sides of the equation by its LCD. So our expression will be x plus 5 times x minus 5 multiplied to the given rational equation x minus 3 divided by x squared minus 25 plus 1 divided by x plus 5 equal to 1 over x minus 5. So if you're going to expand this, we can simplify this expression. So getting the factors of x squared minus 25, that is x plus 5 and x minus 5, plus 1 divided by x plus 5 equal to 1 over x minus 5. So if you're going to multiply both sides of the equation with the LCD, so first expression or first term, we have x plus 5 times x minus 5 multiplied to the x minus 3 over x plus 5 and x minus 5. So both they are common factors, so they are cancelable. So we'll be having x plus minus 3. Then multiply this LCD to the next term, that is 1 over x plus 5. So plus, so common factor is x plus 5. We have x minus 5. Then next expression is the last term. Multiply this LCD to the last term, that is 1 over x minus 5. So x minus 5 are common factors, so we have x plus 5. So let's multiply it with the remaining constant. Okay. So cancel, that is 1 times x minus 3 plus 1 times the x minus 5 equal to 1. Cancelled ang x minus 5, so 1 times x plus 5. So we are going to proceed with our next step. Okay, after multiplying both sides with the LCD, next is to apply the distributive property and then simplify. So we are going to distribute the constant values to these expressions. X minus 3 plus the 1 times the quantity x minus 5 is equal to 1 times the quantity x plus 5. So removing the parentheses, we have x minus 3 plus x minus 5 equal to x plus 5. Simplify by combining like terms. So we have x and x there. We have 2x, negative 3 and negative 5, that is negative 8. So 2x minus 8 equal to x plus 5. Simplify again. Combine like terms. We have 2x minus x equal to 8 plus 5. So x will be equal to 13. Then the last step is to come up with the final answer or final possible values of x. That is, the possible value of x is equal to 13. And the last step is to check each value by substituting into its original equation and reject any extraneous roots. So for this, we have x is equal to 13. Substituting the values of x with 13, we have 13 minus 3 divided by 13 square minus 25 plus 1 divided by 13 plus 5 is equal to 1 divided by 13 minus 5. So 169 minus 25, that is 13 minus 3 is 10, plus 1, 13 plus 5, that is 18, equal to 13 minus 5, 1 over 8. So LCD, we have 144, that is 10 plus 8 for the numerator, equals to 18. Simplify, we have 18 divided by 144 is in simple form is 18, and the other side is 18. Therefore, the value of x is acceptable. Let's try this last example. Solve the rational equation above by following the given steps. The given is 2 over x squared minus 1 minus 1 over x minus 1 equal to 1/2. So first, as you can see, we have on our first term a denominator with perfect square binomial. So we can come up with the factors of x squared minus 1. So we have 2 over x plus 1 times x minus 1 minus 1 over x minus 1 then equals to 1/2. From this, we can come up with the LCD. LCD is x minus 1 times x plus 1. So we have 2 minus 1 times the quantity x plus 1 divided by x minus 1 times x plus 1, which is the LCD, equal to 1/2. So we distribute negative 1 to x plus 1 we have 2 minus x minus 1 over x minus 1 times x plus 1 equals to 1 half. We have 1 minus x over x minus 1 times x plus 1 equal to 1 half. Then we can factor out negative 1 on the numerator. So we have negative 1 times x minus 1 over x minus 1 times x plus 1 equal to 1 half. Now we can see a common factor, which is the x minus 1 on both numerator and denominator. So x minus 1 can be cancelled. And we have negative 1 over x plus 1 equals to 1 half. Then we are going to cross multiply these rational expressions. 2 will be multiplied to negative 1. And x plus 1 will be multiplied to 1. So we have 2 times negative 1 equals to 1 times x plus 1. Then we have negative 2 equals to x plus 1. Find the values of x by transposing negative 1. So we have x is equal to negative 3. That will be our final answer. Our next discussion is on how to solve rational inequalities. The following slides will be a demonstration or steps in solving rational inequalities by using given examples. Our first rational inequality is 3 over x minus 2 less than or equal to negative 1. First step is to put the rational inequality in general form. The general form will be the function of r of x over the function of q of x is greater than 0, where this inequality symbol greater than can be replaced by less than or equal to, and greater than or equal to, depende po sa given. Now, the general form of this rational inequality is by transposing negative 1 to one side, and we have 3 over x minus 2 plus 1 less than or equal to 0. So next is to write the inequality into a single rational expression on the left side. So from our general form, 3 over x minus 2 plus 1 is less than or equal to 0. So we can see we have to come up with the LCD. So from this expression, our LCD is x minus 2. Then from x minus 2, we have 3 plus 1 times the quantity x minus 2 over x minus 2 is less than or equal to 0. Simplify this expression, we can have x plus 1 over x minus 2 is less than or equal to 0. Now our next step is to set the numerator and denominator equal to 0 and solve the values you get, which are called the critical values. Now we are going to solve for the critical values from the general form, x plus 1 over x minus 2 less than or equal to 0. The numerator is x plus 1, therefore the critical value is negative 1. Now for the denominator, x minus 2 equal to 0, therefore the critical value is equal to 2. The next step is to plot the critical values on a number line, breaking the number line into intervals. Negative 1 is the critical value of the numerator, while 2 is the critical value of the denominator. Now when x is equal to 2, substitute the value of 2 to the original given rational inequality. We have 3 over 2 minus 2 is less than or equal to 2. 2 minus 2 is 0, so 3 over 0 is less than or equal to negative 1. 3 over 0 or 3 divided by 0 will give you an undefined solution and definitely not equal to negative 1. Therefore, x equal to 2 is not a solution. The next step is to select the test values in each interval and substitute those values into the inequality. Now take note, if the test value makes the inequality true, then the entire interval is a solution to the inequality. Now if the test value makes the inequality false, then the entire interval is not a solution to the inequality. So let's base our values for of x to this from this number line. So first interval is the values -1 and beyond. And the second interval is from -1 to +2. And the third interval is 2 to positive infinity. So let's test the values that can be found under the first interval. So we have x is equal to -2. Substituting to the inequality, we have 3 over -4 less than or equal to -1. So this is false, therefore the interval or the first interval is not a solution. Next is we try the next interval, the values that can be found on the second interval, which is between -1 to 2. So we use 0 for the values of x, for the value of x. 3 over 0 minus 2 less than or equal to -1. We have 3 over -2 less than or equal to -1. That is -1.5 less than or equal to -1. That is true. Therefore, that interval, -1 to 2, is a solution, is considered as the solution of the inequality. Now let's try the values that can be found on the third interval. That is x is equal to 3. Now, if x is equal to 3, we have 3 over 3 minus 2 less than or equal to -1. So 3 minus 2 is 1. 3 over 1, we have 3 is less than or equal to -1. Since this is false, therefore, the third interval is not a solution of the inequality. Now, the final step of the solution is use the interval notation or set notation to write the final answer. So since the true solution on the testing the values, we have the -1 to +2 interval. So writing its notation or the interval notation we have, so we can see a bracket -1 to the value of 2. So you can see bracket and a parentheses on the other side. So if ginagamit po natin yung bracket kapag ito ay included sa values of x. Now parentheses, therefore 2 is not included as the value of x for the solution of the inequality. Let's find the solution for this given rational inequality by following the given steps previously. So first step is to put the rational inequality in general form. That is, equating the rational expression to 0. So we have here a greater than or equal to sign. So transposing 2 on one side, we have 3 over x minus 2 minus 2 greater than or equal to 0. Next step is to write the inequality into a single rational expression. So from the general form, 3 over x minus 2 minus 2 greater than or equal to 0. LCD is x minus 2. X minus 2 is 3 minus 2, the quantity x minus 2 greater than or equal to 0. Applying the distributive property, we have 3 minus 2x minus 4 over x minus 2 greater than or equal to 0. Simplifying, we have 7 minus 2x over x minus 2 is greater than 0. Now we proceed to our next step, which is equating the numerator and denominator to 0. Numerator is 7 minus 2x equals to 0. Now, 2x, negative 2x, transposing 7 on the other side, we have negative 7. Transpose negative 2, we have x is equal to negative 7 over negative 2. This will give you 3.5. Now for our denominator, which is x minus 2 equal to 0, our critical value is x equal to 2. Then the next step is to plot the critical values on the number line, then breaking the number line into intervals. So we have here a number line. Let's just estimate the points. So we can start from 0, 1, 2, 3. So our critical values, we have 3.5, so it can be found here. And another one is the positive 2. Okay, so our initial form of the plot or of the dot is a hollow circle. So let's test the critical values if they are considered as solution. So first we have with x is equal to 3.5. So substitute the value of x on the original or on the given rational inequality. We have 3 over 3.5 minus 2 is greater than or equal to 2. That is 3 over 1.5 is greater than or equal to 2. Therefore, we have this is a true solution. Since 3 over 1.5 is equivalent to 2, that is greater than or equal to 2. Therefore, we are going to blacken or shaden this point of the value 3.5. Now, if x, let's test the other critical value, which is 2. Now, if x is equal to 2, 3 over 2 minus 2 is greater than or equal to 2. So this will be 3 over 0 greater than or equal to 2. This will give you an undefined solution. Greater than or equal to 2, therefore this is not a solution. So we retain the dot into a hollow. So ibig sabihin nun, hindi po included ang value of x na 2. Dito po sa shaded, ibig sabihin po nun, yung 3.5, critical value of 3.5 is included as solution of the inequality. Now, next step is to substitute the critical values on the inequality, so which is found on the interval. So let's have the first interval. So this is our first interval, this is the second, the third interval. First interval is from negative infinity to positive 2. This is negative infinity to positive 2. Okay, since this is hollow, so we are going to use a parenthesis. Now for the next interval is 2 and 3.5. So 3.5 is included. We're going to use the bracket and a parenthesis on 2. Now for the third interval, from 3.5 to positive infinity. So parenthesis po dun, and this will be a bracket. Now let's test the value that can be found on the first interval. So if x is equal to 0, that is within the first interval. So we have 3 over 0 minus 2 greater than or equal to 2. So 3 over negative 2, that is negative 1.5. So this is not a solution. Now next is if x is, for the second interval, if x is equal to 3. Now if x is equal to 3, 3 over 3 minus 2 greater than or equal to 2. This will give you 3 over 1 greater than or equal to 2. Yes, it is a solution since 3 is greater than or equal to 2. Now the next interval is from 3.5 and onwards. So let's try x equal to 4. Now if x is equal to 4, we have 3 over 4 minus 2 greater than or equal to 2. Now 3 over 2 is only 1.5, which is greater than or equal to 2. Since this is false, therefore this is not a solution. Then we proceed with our last step, which is select the test values in each interval and substitute those values into the inequality. And our final answer is our notation, which is 2 to 7/2 or 3.5. Okay, so let's erase this so that it can be seen. Yan. So that will be our interval notation or the solution of our inequality, which is from 2 to 7/2 or from 2 to 3.5. Other textbook shows other way of solving rational inequalities. Now, ito po yung iba din pong way sa pag-solve ng ating rational inequality. So, we are going to demonstrate this by using given examples. So, let us solve this rational inequality. 2x over x plus 1 greater than or equal to 1. First step is to rewrite the inequality as a single fraction on one side of the inequality symbol and 0 on the other side. So here it is. 2x over x plus 1 transposing 1 on the other side will have a negative 1. So minus 1 is greater than or equal to 0. Now we are going to simplify this expression to a single rational expression. So we are going to get the LCD, which is x plus 1. X plus 1 multiplied to the first expression will give you 2x. Then x plus 1 multiplied to the next expression, which is 1, will give minus quantity x plus 1. Simplify. Combining like terms using distributive property, we'll have x minus 1 over x plus 1 is greater than or equal to 0. Now our next step is to determine over what intervals the fraction takes a positive and negative values. So we are going to base on our single rational expression of the inequality, which is x minus 1 over x plus 1 is greater than or equal to 0. So we are going to do the first step, that is to equate the numerator and denominator to 0 to get the zeros of the function or of the expression. Now for the numerator, x is equal to 1. The 0 of the numerator is equal to 1. The 0 of the denominator is negative 1. Upon testing the value of the denominator or the 0 of the denominator, it will give you an undefined solution since it will give you a 0 denominator. Therefore, in our number line, negative 1 will be a hollow dot, while positive 1 will be a shaded dot. Meaning, ang negative 1 ay hindi po kasama sa solution, while the positive 1 is part of the solution. Now, on the number line, we break the number line into intervals. Then, we note the 3 intervals. So, first interval is from negative infinity to negative 1. The second interval is from negative 1 to positive 1. And the third interval is from positive 1 to positive infinity. After the number line, we're going to use the number line on our test point, the intervals on the number line. That will be used on our table of signs. So on the first row of the table of signs, we have the interval. Interval, negative infinity to negative 1, negative 1, positive 1, 1 to positive infinity. The second row will be the test point. So for the between the first interval, we have x equal to -2. Within the second interval, we have x equal to 0. The last interval, we have x is equal to 2. Now, these values of x will be used on the expression in the numerator, the denominator, then on the whole expression. So if x is -2, the sign will be, that is -2 minus -1, -2 minus 1 is -3, therefore it will be negative. Now if x is equal to 0, substitute this value on the test point, on the numerator, which is 0 minus 1, we have negative. Now if x is equal to 2, that is 2 minus 1, we have positive. Now let's proceed with the denominator. Now if x is -2, substituting on the expression in the denominator, -2 plus 1, this will give you a negative. If x is 0, so x, which is 0 plus 1, will give you a positive. If x is 2, that will also give you a positive. Now for the final expression, we have negative divided by negative is positive. Negative divided by positive is negative. And positive divided by positive is positive. Now, which among the intervals is the solution, or are the solutions of the given rational inequality? So we are going to find out by checking on the inequality used. Since the inequality symbol used is greater than or equal to, we then take the positive sign. So ito po yun, the positive sign, that is kung saan po positive na ang sign natin, yun po magiging solution, or the interval, or we consider the interval as the solution of the rational inequality. So as for the last step is to summarize the intervals containing the solutions. So we can use again the number line, and mapapansin nyo po na yung dalawang ends ng intervals are shaded. Ibig sabihin nun, those are parts of the solution, or the intervals are parts of the solution. And we are going to write our final answer in domain notation, which is the domain of x, or where x are sets of real numbers, where x is less than -1, or x is greater than or equal to 1. Or in interval notation, we have -infinity to -1, and 1 to +infinity. Let's try these exercises for our independent practice. Solve the inequality. X minus 2 over x squared minus 3x minus 10 is less than 0. So since the given is in a general form, what we are going to do is to simplify the expression. So what we do is factor out the denominator, where x squared minus 3x minus 10, its factors are x plus 2 times x minus 5. So our rational inequality will be x minus 2 over x plus 2 times x minus 5 less than 0. Next is to get the zeros of the expression. Numerator is x equals to 2. The denominator, which will give you an undefined solution, x is equal to -2, and the other 0 of the denominator is x is equal to 5. Next is the number line. We are going to plot the zeros of the function on the number line. So we have -2, 2, and +5. So all in all, we are going to, and then we break the number line into intervals. So we have 1, 2, 3, 4 intervals. So first interval will be -infinity to -2, -2 to +2, 2 to 5, 5 to +infinity. Next is the test point. So based on our number line and we're going to use the intervals on our table of signs. So on our intervals, we have negative infinity to negative 2, negative 2 to positive 2, positive 2 to 5, positive 5 to positive infinity. Then our test points under the first interval is x equals to negative 5. Second interval, x is equal to 0. Third interval is x is equal to 3. And the last interval, x is equal to 6. Now we're going to test these values on the expression in the numerator and denominator and the overall expression. First, if x is negative 5, the sign will be negative. If x is 0, still a negative. If x is 3, 3 minus 2, that is positive. X is equal to 6, that will give you 4, that is also positive. Then next is on x minus 5. Negative 5 minus 5, that will give you a negative. 0 minus 5, that will give you also a negative. If x is equal to 3, 3 minus 5 is still a negative. And x is equal to 6, that will give you a positive. Now for the expression x plus 2, if x is equal to negative 5, this will give you a negative. X is 0, 0 plus 2, that will give you a positive. X is equal to 3, that is still a positive. X is equal to 6 is also a positive. For our final solution, negative times negative will give you a positive, so therefore negative divided by positive is negative. Now, negative times positive is negative, so negative divided by negative is a positive. Negative times positive is negative, then positive divided by negative will give you a negative. Now, all positive, therefore it will be a positive. Since our inequality is less than, we are going to take the values of the negative sign. Therefore, the intervals negative 8 to negative 2 and 2 to 5 are the solutions of the given rational inequality. So the last part is the solution. As you can see on our number line, two parts of the intervals are shaded. So this means that these two intervals are the solutions of our given rational inequality. So circle, circle, and it can be written into forms. X is a set of real numbers where x is less than negative 2, or 2 is less than x, which is less than 5. For interval notation, we have negative infinity to negative 2 and to 2 to positive 5. That's the end of the discussion on lesson 3. Hope you learned something. Thank you for listening. God bless.